Composition of forces. The process of finding out the resultant of a set of forces. The resultant force will have the same effect on the body as compared to the combined effect of all the forces. We have already seen different systems of forces like collinear, concurrent, non-concurrent systems, etc. We will review how composition of forces can be performed for various systems of forces. Let us begin with concurrent force system. The fundamental law of composition of forces is called parallelogram law of forces, which states if two forces acting simultaneously on a body are represented in magnitude and direction by two adjacent sides of a parallelogram, then the resultant can be represented in magnitude and direction by the diagonal of the parallelogram passing through the point of intersection. It is to be noted that component forces need to be drawn considering the actual magnitude and direction. Consider a body subjected to a set of concurrent forces, and the resultant need to be established for the same. Let us apply the parallelogram law of forces to F1 and F2 and establish resultant R1. Repeat the process with R1 and F3 to generate R2. In a similar fashion, combine R2 and F4 and establish the final resultant R. R represents the net resultant of F1, F2, F3 and F4. Now we have arrived at the resultant of a concurrent force system using parallelogram law of forces. The same results can be established using triangle law of forces as well as polygon law of forces, which are in fact derived from the fundamental law. Triangle law of forces. If two concurrent forces acting simultaneously on a body are represented in magnitude and direction by the consecutive sides of a triangle, their resultant can be represented by the closing side of the triangle taken from first to last point. Let us redo the earlier exercise using this law. R1 can be established combining F1 and F2. Following the same procedure, R2, and finally the net resultant R is arrived at. The same result can also be achieved in a faster way using polygon law of forces. As per polygon law of forces, if a number of concurrent forces simultaneously acting on a body are represented in magnitude and direction by the sides of a polygon in order, then the closing side connecting the first point to last point represent the resultant force. It can be seen that forces can be chosen in any order to achieve the result. However, the polygon to be generated in a continuous order. All the methods demonstrated so far are graphical methods and provide a clear understanding of the methodology. However, graphical methods require precision drawing tools and not so convenient at many occasions. So, an analytical method is required to analyze complex problems in a faster way. Now, let us discuss analytical solution for parallelogram law of forces. As per parallelogram law of forces, F1 and F2 acting at location A will have a resultant R. Let us discuss about the analytical solution for the magnitude and direction of the resultant. Let the angle between F1 and F2 be theta and alpha be the angle produced by the resultant with force component F1. Name the parallelogram A, B, C, D. Drop the perpendicular from C and extend AB to meet at O. Consider triangle AOC. As per Pythagoras theorem, AC is square root of AO square plus OC square. We can see that AO is AB plus BO. AC is the resultant R for which the magnitude and direction need to be established. AB and AD are the applied forces F1 and F2. From the geometry, BC will also be F2 and angle CBO will be theta. From the triangle CBO, BO by BC will be cos theta. So BO becomes F2 cos theta. In a similar way, OC will be F2 sin theta. Substituting these, the equation becomes R is equal to square root of F1 plus F2 cos theta whole square plus F2 sin theta whole square. Rearranging, the equation becomes R is square root of F1 square plus 2 F1 F2 cos theta plus F2 square. Thus, we have arrived at magnitude of resultant force expressed in terms of magnitude of the component forces and the angle between them. Now, we need to have an expression for the direction of the resultant force. From the triangle CAO, tan alpha is OC by AO. Substituting, tan alpha becomes F2 sin theta divided by F1 plus F2 cos theta. And the angle alpha will be arctan or tan inverse F2 sin theta divided by F1 plus F2 cos theta, where alpha is the angle the resultant make with force F1. With these equations, resultant of two concurrent forces can easily be found out. The process can be repeated in case of additional forces. Now, let us review some special cases of this analytical solution. Consider two concurrent forces as seen. When theta is 0, cos theta will be 1 and sin theta will be 0. The equation becomes R is equal to square root of F1 plus F2 whole square, which is nothing but F1 plus F2. When it comes to the direction, tan alpha will be 0 and angle alpha will be 0. So, the resultant will be acting at an angle 0 to force F1. It can be seen that when theta is 0, the forces become collinear forces in same direction. The magnitude of the resultant force will be summation of both the forces and the resultant will be acting in line with force F1. Now, consider the scenario when theta is 180 degrees. At 180 degrees, forces become collinear forces in opposite direction. Cos 180 will be minus 1 and sin 180 will be 0. The magnitude of the resultant R will be square root of F1 minus F2 whole square, and this will be same as F1 minus F2. So, for collinear forces, magnitude of resultant force will be algebraic sum of component forces and the direction will be same as the larger component. Details of composition of non-concurrent forces are covered in a separate video. Now we have seen graphical and analytical solution for fundamental principle of composition. When it comes to complex force system with large number of component forces, application of parallelogram law of forces become tedious and it is good to have a generalized method of composition. Details of the same are covered in the next video.